radiation. And I made this presentation along with two other partners, Bobby and Nikita. Unfortunately, the two of them couldn't be here tonight, so I'll be covering for them. And first, I'm going to tell you about what is radiation, just in general. And radiation is basically energy moving through wavelengths or rays at different variable spectrums. And the first radiation I'll be talking about is cosmic radiation. And cosmic radiation, which is also called galactic cosmic radiation, is the most common kind that you'll be dealing with if you are going on a space mission. It is believed to be the remnants of supernovas, which, if you don't know, is an explosion at the end of a star's life when it becomes so dense that it basically implodes on itself. And it is composed of high-speed particles, and it can actually damage your DNA because the particles from cosmic radiation can pass unimpeded through ship materials like your aircraft or even your skin. And then we have one thing I've just remembered to mention. Cosmic radiation is basically the nuclei of atoms that have been stripped of their electrons. So you have the nucleus and you have the electrons orbiting it in the various electron shells. Well, those electrons have been stripped away, and now this nuclei is moving at almost the speed of light, and that's what this cosmic radiation is composed of. And then Bobby linked in a video for us to watch, so you can just play that.
About 2 or 3 times a century, a massive star in our galaxy explodes. The star's core may survive as a neutron star or a black hole, but the rest of it rushes into space as swiftly expanding debris behind a powerful shockwave. As the supernova remnant grows, it sweeps up interstellar gas and gradually decelerates. Yet even thousands of years later, its imprint on the galaxy remains impressive. Exploding stars and their remnants have long been suspected of producing cosmic rays, some of the fastest matter in the universe. Where and how these protons, electrons, and atomic nuclei are boosted to such high speeds has been an enduring mystery. Now, observations of 2 supernova remnants by NASA's Fermi Gamma Ray Space Telescope provide new insights. Because cosmic rays carry electric charge, their direction changes as they travel through magnetic fields. By the time the particles reach us, their paths are completely scrambled. We can't trace them back to their sources. So scientists must locate their origins by indirect means, which is where Fermi comes in. The interaction of high-energy particles with light and ordinary matter can produce gamma rays, the most powerful form of light. Unlike cosmic rays, gamma rays travel to us straight from their sources. In 1949, physicist Enrico Fermi worked out how what he called magnetized clouds could accelerate cosmic rays. Later studies showed that a variant of his method, called Fermi acceleration, worked especially well in supernova remnants. Confined by a magnetic field, high-energy particles move around randomly. Sometimes they cross the shock wave. With each round trip, they gain about 1% of their original energy. After dozens to hundreds of crossings, the particle is moving near the speed of light and is finally able to escape. If the supernova remnant resides near a dense molecular cloud, some of those escaping cosmic rays may strike the gas and produce gamma rays. But electrons and protons make gamma rays in different ways. Cosmic ray electrons do so when they're deflected by passing near the nucleus of an atom. Accelerated protons may collide with an ordinary proton and produce a short-lived particle called a neutral pion. These pions quickly decay into a pair of gamma rays. At their brightest, both types of emission look very similar. Only with sensitive measurements at lower gamma ray energies can scientists determine which process is responsible. Now, Fermi observations have done just that. They conclusively show these supernova remnants are accelerating protons. When they strike protons in nearby molecular clouds, they produce pions, and ultimately, the gamma ray emission Fermi sees. NASA's Fermi has detected gamma rays from many more supernova remnants, but the jury is still out on whether accelerated protons are always responsible, and what their maximum energies may be. Nevertheless, the Fermi team has taken a major step, a century after the discovery of cosmic rays, in establishing just where they arise. Something that would satisfy, but certainly not surprise, the original Fermi.
Alright, so just a quick summary of that video. That was basically just a recap of the history of how we discovered what this cosmic radiation was and how we were able to observe it and figure out, kind of get a basic understanding of how we think it works. Yep.
I don't know what I did.
Yeah, you have to present. We have a few more videos in here, so
Oh,
you'll have
okay,
to
sorry.
probably do that again.
Okay. Alright.
All right, and then our next one we will talk about is ultraviolet radiation, and this was Nikita's portion of the project. And ultraviolet radiation, I'm sure most of you've heard of. That's the kind that they warn about when you go out in the summer. That'll give you a sunburn. That's why you put on that sunscreen. And it is expelled from the sun. And one interesting thing about the sun is that it expels energy on every part of the electromagnetic spectrum. So ultraviolet radiation is one of those. It also visible light, which is what you can see with your eye, infrared, gamma rays, X-rays, and so forth. And the problem with this, when you run into, especially when you go into missions into deeper space, when you're out there for much longer, is it actually causes a degradation of the materials that are commonly used, such as polymers and thermal paints, which is a problem, obviously, because if that starts degrading, then how are you meant to, keep your ship stable and be able to get back, especially if you're sending manned missions out that far. Right, and then the third part is what I did, and this is just protection from the radiation, because obviously it's very harmful to humans, so these are just some ways we figured we could protect from that if we were on a moon colony. We have two different types. We have how to protect your person, so your body from it, and then shelter protection as well. And so we quick have a video from NASA about the effects of this radiation on the body and how to protect from it. This video is actually designed for Mars missions, so the manned missions to Mars that they're proposing, but the same principle apply to a colony on the moon as well.
Mars gets all the glamour.
Yeah.
So frustrating.
And this is from NASA, by the way. I mentioned
So of all the things that the Human Research Program is investigating, the biological consequences of radiation exposure is one of the major ones. Some of the reasons for that is that the health consequences following radiation exposure are very complex processes. It's difficult to quantify exactly how the radiation is interacting with tissue, and then it's even more complicated to try to quantify and determine what the long-term outcomes are going to be in terms of things like carcinogenesis, central nervous system effects, and detriment to the central nervous system.
The primary means by which radiation affects cells is by damaging their DNA. You can get breaks in the strands in the double helix, you can knock bases out, and the cell will make an attempt to repair that damage. Sometimes it's effective, sometimes it's not, and sometimes it'll actually get repaired, but in an error-prone fashion, so it's what we call misrepaired. So anything that sets into the genome in that way is a mutation, and the accumulation of mutations can potentially lead to cancer and take a non-cancerous cell, a normal cell, and make it transformed into a cancerous one, so that's a big concern.
So on Earth, there's a couple characteristic things that are different from space. One of them is that the type of radiation we experience on Earth is generally what we refer to as low LET radiation, things like gamma rays and X-rays. We also have the protective shielding of the Earth's magnetic field and the atmosphere, which shields a great deal of the radiation. And then finally, we have things like radiation protection concepts such as time, shielding, and distance. So we can reduce the time of exposure on Earth, we can reduce the distance from the radiation sources, and we can reduce the exposure through shielding. In space, a lot of those things are very different. So we have a very complex radiation field that includes things like protons and all the particles on the periodic table of elements. They're coming in at energies that are approaching the speed of light, and they're difficult to shield against. And they're always there. So the concept of time really doesn't make sense because you can't reduce the exposure in space except perhaps getting to Mars faster. You can't really reduce the distance at all because the radiation is everywhere. And shielding concepts for galactic cosmic rays are very difficult because of the energies involved.
So I was just talking about kind of what radiation is and how they're trying to combat that. And as Mr. Ward said earlier with Scott Kelly, yeah, it does, like, the radiation will do damage to your DNA. And I mean, your DNA will repair itself. The problem is won't always repair itself correctly. So you'll have these fixes, but they'll be erroneously fixed. So it might mutate or cause some sort of change, which is a problem, but we don't exactly know what that means exactly. And then this is just some of the shelter radiation protections. The Australian National Academy has developed this sort of nanoweave, which is like sort of a mesh that's made out of these nanofibers, which is very light, and it can not only be used to layer over your suit or yourself to protect you, but we also believe that it could be made in these big sheets, which could be used to layer over human buildings that we could build. Because it's so light, it wouldn't be hard to transport. And then another one is 3D printed structures. Now when most of us think of 3D printing, you think of, you design the little cube on your computer and then you print it and the little thing goes around and it makes a little plastic cube. Well, this is actually a lot bigger than that. This is actually taking rocks and dust from the surface of the moon, spraying it with a printing agent, and being able to layer that over a sort of a pre-made tent, so to speak, in order to create settlements for human colonists. And I found a really good video of that from the European Space Agency, who actually proposed this idea. And when you get this up and running, you should skip to the 2-minute mark,
Okay.
because that's when it really starts. So about 2 minutes, yeah.
And is on a course to Shackleton's crater, the moon's south pole. Inside the lander is a cylinder which contains an inflatable dome and 2 robot 3D printers. After the cylinder containing the habitation capsule has been unloaded, a dome is inflated from one end. This provides the support structure for construction. A little like scaffolding is used to build on Earth. The lunar habitation is built by a robot-operated 3D printer. At one end, it has a scoop to collect the regolith. In the center are the containers for the printing material. At the other end, there is a robotic arm with a printing head. The robot collects regolith from the moon's surface. Layers of this moon dust are built up over the dome to create the protective shell. This process takes about 3 Earth months. The shell is made up of a hollow, closed cellular structure. Under a microscope, it would look very similar to the close-up of a bird's bone. Like a bone, it is light and incredibly strong at the same time. When the lunar base is complete, it can house 4 people. Inside the dome, they are protected from meteorites, gamma radiation, and high temperature fluctuations. The original capsule functions as an airlock and technical support module. The skylights draw daylight into the living and workspaces, which are sheltered within a pressurized enclosure. This method is a pioneering advance in space-age construction. At Foster & Partners, we're used to designing for some of the world's most extreme climates. We often use materials found locally to create sustainable buildings on Earth. While the moon is an exciting new territory for architecture, the value of this logic endures.
Alright, and then that's basically the end of it. So yeah, that's basically their idea about 3D printing, homes for humans on the moon, which would be really cool. If you notice, the one they had modeled there kind of was an igloo shaped, and that's because the dome is actually very stable, and it would offer the best protection not only from the pressure, but also from incoming meteoroids. If that hit, it would absorb the impact better. And it would also create a more confined environment for the pressure inside the home that humans would need to survive and live, without wearing a suit all the time. That's the end of our presentation. So